Okay, so today we're going to be learning about fresh water. And what's amazing is that two-thirds of the fresh water on Earth is frozen in the form of either glaciers or icebergs. And glaciers are large sheets of ice that form in cold parts of the world. These sheets of ice form when layers of snow continue to form on top of one another. And as the snow accumulates and gets heavier, the increased pressure compacts the snow into a dense block of ice. So it just gets heavier and heavier. So for a glacier to form, there must be more snow accumulation than snow melt. Alpine glaciers tend to be smaller because they form at high altitudes in the mountains, where continental glaciers cover very large flat areas of land. And this image is coming to you from the Patagonia Mountains in Argentina of South America. So there's alpine glaciers and continental glaciers. The other way we have fresh water on Earth is through icebergs. And icebergs are large blocks of ice that float in the ocean. They're formed when a glacier extends out over the sea and a big chunk of it is broken off due to gravity. Icebergs have been known to be as large as the state of Connecticut in the United States and can reach as high as 45 meters out of the ocean. But here's the real kicker. Only about 1/8 of an iceberg rises up out of the water. So that means close to 87% of an iceberg is hidden beneath the surface. Check this out. This just goes to show how icebergs float. Here's the top. This is what we see sticking out of the water. Here's the massive ice chunk under the water. So now you can see why the Titanic wasn't even, that close to the iceberg up on top, but it hit down below. It's just incredible. So where is all the fresh water? After it rains, the rainwater can do one of three things. It can either flow into a river or lake, it can evaporate and become water vapor, or it can sink into the soil. And here is our water cycle, which I'll give you a second to just take in. So without the sun, the water cycle would not work. And as you can see, here's our lake, our ocean, our river that is being evaporated up by sunlight. And that water has to go somewhere. It goes up into water vapor, which then forms in clouds. And depending on where those clouds are located and the temperature of the atmosphere determines what kind of precipitation will fall down, whether it's snow or rain. And once it hits the ground, that runoff is going to go into these rivers, as you can see, and some of it's even going to sink into the ground. That's where we get our groundwater from. And it just keeps going. Now, groundwater is super fascinating because the water that sinks into the soil and collects underground is what we call groundwater. And in order for water to collect, there has to be an area of rock that the water can travel through, containing the water until it hits an area of rock it can't go through, stopping it from sinking any further. So what we have are permeable substances. Permeable substances are things that liquids can flow through. So think of soil, think of gravel. Water can seep into all the spaces between soil, gravel. However, liquid cannot travel through impermeable substances. So water stops sinking once it hits a layer of impermeable rock, like granite or marble. And this creates an underground where water is collected in the permeable rock and soil and is held there by the impermeable rock beneath it. Now, the upper surface of the stored water, the point at which you reach earth saturated with water, so like if you would dig and all of a sudden you'd be like, oh, I struck water, it's called the water table. The entire area where the water has been collected is called an aquifer. And you can kind of see how water would be able to go through all these cracks and spaces. And then again, once you dig deep enough, you hit the water table, which is just the point of where water is located. But that whole area is called an aquifer. How do we get that groundwater out? Well, often through a spring or a well or even a hot spring. So some of you might be familiar in your neck of the woods, especially in Wisconsin, that there are natural springs where water flows out of the ground and it's lower than the water table. It could be possible in hilly and mountainous regions where the water table is higher than land on the lower slopes and the water is just really pushed out through a break or hole in the area. Oftentimes, especially in southwest Wisconsin, I've been able to visit springs that have such good tasting, clean water. Versus a well, now this is an old fashioned well where there's an actual hole in the ground, which is drilled deep enough to reach the water table, which exposes the fresh water underground. Man made wells have been used for thousands of years as a way to access this fresh water. Many of those of us who live in the country have our own well. And then, of course, we get the hot springs. Oof, maybe you were lucky enough to visit a hot spring in your lifetime. Maybe it's on your bucket list. But when groundwater is deep enough in the earth to be exposed to intense heat, it can start the water to boil. And the pressure of that boiling water creates a hot spring when it's great enough to push upwards, break through weaker rock, and reach the surface. If you've been to Old Faithful, it's a famous geyser that erupts violently from Earth's surface, located at Yellowstone National Park in Wyoming. Now, all plants need water to grow, right? Irrigation is a way that farmers use water to supply large crop fields with enough water to sustain them. Sometimes they'll use spray irrigation using these large pivoting sprinklers to spread water over crops. Another way to irrigate is by flood irrigation. It's more complex of getting water to plants by digging a series of ditches and canals. And when you dig these ditches and canals, you fill them with water, and then you use tubes to pull out the water onto the fields. I see a lot of this type of irrigation in our state. Now, here's the big deal. Many countries experience water shortages, making drinking water harder to come by, forcing countries to import crops because they don't have enough fresh water to irrigate their own. Sometimes water shortages are caused by unexpected events like droughts, where they don't get adequate rainfall for a very long period of time. Too often, though, water shortages happen because of overuse. This is something that we will all have to watch and be wary of in the future because the demand for water is growing, especially as our population grows. We can't live without water. So we need to find a way to make sure that everybody has equitable access to it. We really have to be careful. We can't take too much water from the ground. Maybe you've heard stories about the Colorado River. Colorado River used to be a raging river. In the 1950s, it looked like this. This is an image of today, and this is a lucky image of today. The Colorado River flows down into Mexico, and oftentimes this Colorado River is just a trickle. So we really have to be careful. We can't take too much. Now, there are ways to make more fresh water, but it is expensive. One is called desalination. Desalination is where we take salt from ocean water. And another way is to melt down icebergs. Here's the problem. They're expensive, they're difficult, and they're time consuming.
The Earth's population.
All right. Your job is to work in Acellus, steps 115 today through 126. And you may go ahead and get to work.